Okay, we're going to do some more examples of finding normal probabilities. This is for any normal distribution. You can think of it as finding X-score probabilities. And so if you recall, this uses those 5 steps. You write out the X-score probability, draw a diagram, calculate the Z-score, write out the corresponding Z-score probability, and then calculate the corresponding Z-score probability. So, in this example, the wait time at a popular restaurant, so the time you wait to be seated, is normally distributed with a mean of 23.4 minutes and a standard deviation of 3.7 minutes. Okay, so some people get seated in less than that, some people get seated more than that, and it's normally distributed. Okay, and so we're going to find these 3 probabilities. So the first one, I'm going to find the probability that it's less than 15 minutes. Okay, so the first step is we write out the Z-score probability, and maybe I'll zoom in here. Okay, and then if I can autofocus here. Okay, so we're going to write out the X-score probability. So I want the probability that X is less than 15 minutes. So that's like my X-score probability. Okay, so the second step is I'm going to draw a diagram. Okay, in the center is the mean, which is 23.4 minutes. And I know you can't see that there. I'm zoomed in, but it's 23.4. The standard deviation is 3.7 minutes. And now 15 is actually going to be below the mean quite a bit, you know, maybe, I don't know, maybe about there. It doesn't have to be perfect, but there's 15 minutes, let's say. And I want one of the wait times that are less than 15 minutes. So that's this area down here. All of these are more than 15 minutes. These are less than 15 minutes. Okay, so that's my diagram. Now I got to calculate the Z-score. So that's the third step. So I'm going to convert 15 into its corresponding Z-score. So I take 15 minus 23.4, and then I'm going to divide that by 3.7. And that's going to give me the Z-score. So, got to put this in the calculator, right? 15 minus 23.4, hit return, and then divide the difference by 3.7. And I get negative 2.27. 2.27. Okay, and so the fourth step, if you remember, excuse me, this step is writing out the corresponding Z-score probability. So I'm going to change that X to a Z, less than, and change the 15 to this corresponding Z-score, which is negative 2.27. Okay, so that is actually pretty far out. That's pretty extreme. That's beyond 2 standard deviations. Okay, so now we can find this area. So this now is just finding the Z-score probability. It's one of those 3 cases here. In this case, this is the less than case. So all I have to do is look up the Z-score on the table here, and the area on the table is the desired probability. So I look up negative 2.27 way over here, and what I get is 0.0116. So this is 0.0116, and that's the answer to my problem. That's the 5th step. The 5th step is finding the Z-score probability. I'm sorry, yeah, finding the Z-score probability. So another way to think of that is of all the people in the restaurant waiting to be seated, you know, little over 1% of them are going to wait less than 15 minutes. Okay, so most likely you're going to wait more than 15 minutes, right? So now we're asking the question, what's the probability that you're going to wait more than 20 minutes? Okay, so maybe I'll divide this here. So the first step here is write out the x-score probability. So this is a greater than 1. X greater than 20. Okay. Step 2 is we draw our diagram. Okay, the mean is 23.4. Standard deviation is 3.7. Okay, now 20 is still below the mean. Okay, the mean is 23.4. Okay, so don't make the mistake and think, oh, if it's positive, it's always on this side. Okay, because when you're dealing with the x-scores, the middle isn't 0. The middle is the mean, right? If these are z-scores here, then the middle's 0. But if there are x-scores, then you're going to, if the value is below the mean, you're going to put it on the left. And 20, that's not that far below the mean. So, you know, less than 1 standard deviation. So maybe I'll put it right there. And I want to know what's the probability that I'm going to wait more than 20 minutes. Okay, so it'll be this area right here. That area. So, so now step 3 is I'm going to calculate the z-score. So in this case it's 20 minutes. I'm converting 20 minutes. So I subtract the mean, 23.4, divide that by the standard deviation, 3.7. Okay. So I take 20 minus 23.4, and then I 20 minus 23.4, and then I divide that by 3.7. Okay, and that is negative 0.91. So a little less than 1 standard deviation below the mean, right? So the fourth step is write out the corresponding z-score probability. So I'm going to change the x to a z, keep the greater than sign, and then the 20, I change that to the corresponding z-score. And so now I want to find the probability that z is greater than negative 0.19. Okay, so when I look that up, that's going to give me the area below. So we'll start there. So on the negative side, negative 0.9, what was it? 0.91. And what I get here is 0.1814. 0.1814. And of course, the area that I want is the area above. Okay? So remember, when I get to this point, I'm going back to those 3 cases, and I have a greater than probability, and so this is where I look the area up on the table, subtract from 1, and that gives me the area above. So 1 minus 0.1814, that gives me 0.8186. And that's my desired probability in this case. 186. And if you wrote it as a percentage, what this would mean is out of all the people waiting to be seated, 81.86 of them will wait more than 20 minutes. So there's a pretty good chance that you're going to wait more than 20 minutes. Okay, according to these numbers. So now the final one. This is between 30 and 35 minutes. So we now have a between probability. And the way that you write this is you're going to write out the x-score. You're going to put 30 on the left, 35 on the right with x in between them. And then you're going to use less than signs. So it would be 30 with the less than sign, x with the less than sign, and then 35. So it would look like that x is between 30 and 35. Both of those are less than signs. And we want to find the probability that they're between 30 and 35. Okay, so in this case, The mean here is 23.4. Standard deviation is 3.7. So 30 and 35 are both above the mean, and 30 is over one standard deviation above, and 35 is way up there. So maybe something like that. I've got this area here. And so what I'm wanting is the area between 30 and 35. Okay? So that's my second step. So now the third step, I have to calculate the z-scores. So for this, I need to convert both of these into their corresponding z-scores. So I'll have to use the formula twice. 30 minus 23.4 divided by 3.7. So that'll be ones. Okay, so 30 minus 23.4 divided by 3.7. Oops, I did something wrong here. 30 minus 23.4 divided by 3.7. I think my 0 button sticks, so sometimes it doesn't put the 0 in there. So there we go. That is 1.78. So that's almost 2 standard deviations above the mean, isn't it? Okay, and then now I got to calculate the z-score for 35. So 35 minus 23.4 divided by 3.7. That's not 3 minus 7, it's 3.7. Okay, so 35 minus 23.4 divided by 3.7. And I get 3.14 when I round to 2 decimal places. So these are the two z-scores. So now I'm going to convert this into the corresponding z-score probability. And it'll be a between probability. You'll have 1.78 down here, 3.14 up there with z in the middle. So it's the probability that z is between 1.78 and 3.14. Okay, so now I've reduced this down to its z-score probability. So now it's of those 3 cases, less than, greater than, between. This is a between probability. So this means I have to look both of these up, find the 2 areas, and then you subtract the 2 areas. They're both on the positive side, so 3.14, I get 0.9992. So this is 0.9992. And then 1.78, so this is 1.78. And I have 0.9625, so this is 0.9625. Okay, so I gotta subtract to get my final answer. I gotta subtract these 2. So I get 0.9992 minus 0.9625. And what I get here is 0.0367. And that is my final probability. And if you wrote that as a percentage, you'd get like 3.67%. And this would be of all the people waiting to be seated, 3.67% of them are going to wait between 30 and 35 minutes. Okay, so not very many of them. Okay, so let me zoom out here for a minute and just make a quick comment. And that is, when you look at what we did, and you probably already recognize this, what I did is I did an example of each of the 3 cases. So there's the less than case, the greater than case, and the between case. So in each one, you're using the 4 steps to reduce it down to one of those z-score probabilities. And then you got to take and use one of those 3 cases to find the z-score probability. So that is how you do these. So even though these look like story problems, which kind of can be scary. They're not story problems at all. Every single one of them, you're going to have a normal distribution. They're going to give you the mean and standard deviation, and then they're going to ask you to find either a less than probability, a greater than probability, or a between probability, and you just use the 5 steps and those 3 cases in order to do that. So, okay, on the next video, we will learn how to do this backwards.